All right, so hopefully you had a relaxing break type thing, if you want to call it that. Time off, week off almost, hurt near. I have your tests graded, but I want to focus in on the new material for today. If there's time at the end, I'll handle that. But I want to make sure that we have plenty of time for this. One of the things that I'm going to tell you flat out is I saw all of your test scores, and some of them were not good. Some of them were great. Some of them were not good. Most of them were kind of in that, could have done better, made some dumb mistakes, didn't put, factored when I should have solved kind of a deal, got off at the wrong bus stop type thing. And I'm not going to lie to you, a lot of that has to do with reading the directions. Okay? And even more so than reading the directions, because I told you numerous times that you should read the directions. A lot of it has to do with in-class type stuff. A lot of phones are out. And it shows. Your grades show that there's phones out and that's more important than, understanding the material, taking notes, all that stuff. Okay? If you don't understand something, when is the time that you should say something about it that you don't understand? When's the time that you should let somebody else know that you don't understand? Like if you don't understand what a rational function is, when should you ask what a rational function is? Now or in a month and a half when we take the test on this stuff? Now would be the time, right? Okay? So don't be afraid to ask questions. There's going to be a lot of terminology and a lot of logic this week. Okay? That logic will get easier towards the end of the week when we start graphing. Yes, graphing is going to make this stuff easier on you. Okay? But up until we get to the graphing part, there's going to be a lot of thinking going on. And so if you don't understand the thought process that goes into it, you need to ask that. Or, like on Wednesday, rewatch the videos. Side note, you're going to have 2 videos to watch in class on Wednesday. I, unfortunately, will not be here again. So make sure that you bring your Chromebook and your earbuds, or you can watch it on your phone too, but it's a little bit bigger on a Chromebook screen than it is on your phone screen. So, okay? Good? Okay. So, with that being said, 1, I should not see a phone out anywhere. 2, I shouldn't see a purple worksheet out because that's not our focus right now. The only thing that should be out is your notebook. Okay? All right. So, Unit 4 is going to take us all the way up to winter break. So we're going to test on this unit the Thursday of the Thursday of winter break. So whatever that is, 22nd, I think? I think it's 22nd. Okay? So December 22nd is going to be the test on unit 4. Okay? So what it's all about? It's all about rational functions. You did these back in Algebra 2. Okay? So it should be review. We're going to add in a couple of things to go along with it, a couple of different parts. We're going to add into it, but yeah, we can definitely handle it. All right, here we go. So from Unit 3, we talked about this, and I know this was oh gosh, probably even a month ago we talked about this. Does anybody remember what a rational number is? Number that can be written in the form of rational number. We talked about when we did the rational zero theorem. Anybody remember? No? It's rare that you hear me refer to it as a rational number, so that's fine. But it's a number which can be written in the form of a fraction. So a rational number is a fraction. Anything that can be written as a fraction. So what do you think then a rational function, come back to me, a rational function is? A what? What written as a fraction? A function, okay? So it's a function written as a fraction, okay? Which means that you're going to have two functions. You're going to have a function in the numerator and a function in the denominator. The kicker is that q of x, the denominator, can't be 0. But that just comes from the fact that we can't divide by 0. P of x can be 0, but q of x cannot be 0. So some examples of that would be like f of x equals 4 over 3x plus 5. That's a rational function. That's a rational function. That's a rational function. It's ugly, but it's rational. Okay? Those are all rational functions. Now, later on, in a few minutes, you're going to start a list. And that list is what is the steps that you're going to do every single problem. Okay? So it's a very important list that we're going to generate. And the very first thing for now on that list is going to be finding the domain of our function. And the domain of our function is what are the numbers, the x values, that we can put into this function and have it work out. So the domain of a rational, or the domain of a rational function includes all real numbers, and side note, all real numbers, you're going to need to get to know this symbol. It's a double vertical R. That's the mathematical symbol for all real numbers. So you don't have to write out the 3 words. You can just put that symbol. And anybody in the world, even in Italy, will know what you're talking about. Okay? So all real numbers. Okay? So the domain is all real numbers except the x values, which make the denominator 0. So if I am going to find the domain, I am going to set the denominator equal to 0, and I'm going to solve it. And those values that I get, those are going to be the restrictions in my domain. So for instance, I think I have a for instance on the next slide. So for instance, let's say f of x here, I'll make it be easy, was x equals 1 over 2x plus 4. Okay? That's our rational function. The very first thing, if I am going to find the domain, I'm going to set my denominator equal to 0. So that's going to be 2x plus 4 equals 0. And I'm going to solve that then. Subtract 4 from both sides. Divide by 2. And I get x equals -2. So the domain of this rational function would be all real numbers, but x cannot equal -2. Because if I put -2 back into this function, 2 times -2 is -4. -4 plus 4 is 0, and I have 1 divided by 0. And we can't divide by 0. So that's why -2 is something called a point of discontinuity. It's a hole in our graph. It's a break. It's literally a crack in our function. Okay? And so we can't cross over that crack. It's too wide to jump across. Okay? So what happens in these spots where the denominator is 0? Kind of just actually let the cat out of the bag. Okay? So we have there. So this point of discontinuity would be x minus 2 equals 0. X equals 2 there. So our domain here would be all real numbers, but x cannot equal here now +2, because if I plug 2 back in, if I find f of 2, that's going to be 7 over 2 minus 2. And we can't divide by 0. I thought I put it at the bottom of that slide. Apparently not. So what's going to happen there? These spots are going to become vertical asymptotes. So they're going to be lines on our graph. Okay? And we would say here then, right in this very step, the vertical asymptote of this function would be x equals 2. Vertical asymptotes are lines, so I have to give them in line form. I can't just say 2 is my vertical asymptote. 2 is a number. X equals 2 is a vertical line. So, what I would like you to do now, because these steps that we are going to be making are so gosh darn important, I want you to take out a clean, fresh, no writing on it sheet of paper. Okay? Brand new, separate sheet of paper. Okay? Nothing else is ever going to be written on it. Rip it right out of your notebook if you have it. Okay? Because what's going to happen here now is this is going to be your extra sheet. Okay? We're starting your note sheet for the final today. Okay? And so we're going to put the steps, and there's going to be 8 of them. Okay? We're going to put the steps on this sheet, and you're going to have this sheet out at all times for the next month. Okay? You don't do math without this sheet for the next month. Okay? So 1, put your name at the top. 2, put down steps to graphing a rational function. Okay? Now, underneath the title, I want you to save space for step 0. We're not going to get to step 0 until probably a week and a half yet. Okay? But we'll get to it, I promise. Okay? But we're going to save some space for step 0. Okay? So step 1 says we are going to find the domain and any vertical asymptote. Now, we can have more than one vertical asymptote, just so you know. So you have to find them all. How do we go about finding the domain and any vertical asymptotes? We set the denominator equal to 0. And you can put all of that on step 1. Wednesday you'll get step 2. Thursday you'll get step 3. Next week, Monday, I think it's step 4, I want to say. I don't remember when. We'll have 8 total steps. Okay? The first 3 are pretty easy. That's why we can do them in one day. So again, have that sheet out with you at all times, especially like when we're taking notes. It should be notes and then that supplemental sheet right next to it, so that you can, when we get into graphing these things, you follow these steps. Just keep going down the list every single problem. Okay? So now back into your notes. You can again keep that sheet out, okay? Because you want that sheet out there. I want you now to find me the domain and the vertical asymptotes for this function. Go. So, according to our supplemental note sheet, which we just started, we set the denominator, in this case it's 2x minus 5, we set that equal to 0, and then we solve it. So I'm going to add 5 to both sides. That's going to give me 2x is equal to positive 5. Then I'm going to divide both sides by 2. And that's going to give me x is equal to 5/2. Right? Okay. So the domain of this function is going to be all real numbers, but x cannot equal positive 5/2. And that's how I write it. Because if x is 5/2, I'm dividing by 0. Can't happen. Which means then we have a vertical asymptote on our graph at x equals 5/2. Okay. And those are the two things that we ask. Okay? So, before we keep going on with this awesomeness of rational functions, okay, we got to take a pause here, and we got to talk logic. Okay? So, the logic that we need to talk about deals with some fractions. Specifically, if I take a big number and I divide it by a small, not a small number, a small number, if I take a very big number and I divide it by a really small number, 1,000,000 divided by 0.2. Okay? Anybody? What do you think it's going to be? Big? Okay? Huge, right? Okay? It's going to be much bigger than the numerator, which was already a big number. Okay? What if that number, that small number, keeps getting smaller and smaller and smaller? So the answer keeps getting bigger and bigger and bigger, right? Okay? So this is going to end up being some huge number, right? And if this number here keeps getting smaller and smaller and smaller, then this huge number is going to go to infinity, right? Because it's just going to keep getting bigger and bigger and bigger, right? Okay. Now, let's flip that around. What if I have a small number and I divide it by a big number? One divided by 1,000,000. What do you mean it's going to be small? Like it's not smaller than the small one?
Smaller than the.
Okay. Okay. All right. So this is going to be a small number. Now, here's where logic comes in. What if this number keeps getting bigger and bigger and bigger? Until it approaches what? So like on the left one, if the answer, or our result, would approach infinity. What's the answer going to approach on the right? Nope. 0. It's going to approach 0. Okay. So if I have a small number and I divide it by a huge number, that answer is going to be like 0. It's not going to be exactly 0 because there's still numbers involved. Okay. If I have a big, huge number and then I divide it by a teeny tiny one, that's going to be even bigger. Ginormous infinity. Okay. Now, some more logic, this time outside of fractions. Okay. I want to talk about a number that looks like this and a number that looks like that. Now, you may be saying to yourself, Linz, what are you doing to me? Okay? Well, I'm bringing logic into that. And there's a lot of logic in that. So, this left one, 3 with a plus it's up in the exponent spot. Okay? It's not plus 3 out in front. It's 3 and then a little teeny tiny plus up above where the exponent goes. If I'm talking about an x value, that means we are approaching three from the right. So we're on the right side of 3, but we're getting closer and closer and closer and closer to 3. If I'm talking about a y value, we would be approaching three from above. Because on a graph, we're getting to graphs. I'm preparing you for graphs. Okay? On a graph, the x part of a graph is the horizontal, the lefts and the rights. Okay? So you're talking about an x value, 3 plus, then you're approaching from the right side, you're coming into 3. If you're talking about a y value, that's the vertical part of a graph, you're approaching 3 from above. It's open. Now, if I'm talking about 3 minus, then if I'm dealing with an x value, that would be approaching 3 from the left. Because the left side of the graph is the smaller side, the negative side. If I'm talking about a y value, it would be approaching 3 from below. We're going to talk about end behavior and asymptote behavior. Okay? So example number 1 says, find the domain, find the vertical asymptote, and use logic to describe asymptote behavior. That's what the function is doing in and around on both sides of your of any and all vertical asymptotes. And the end behavior, what the function is doing on the left and the right side of your graph. Okay? So, started off with a nice, easy, well-to-do function. Okay? So our function is f of x equals 1 over x. Okay? First thing, we need to find the domain. How do I find the domain from our cheat sheet? Set the what? Set the what? Denominator. Different than domain. Yep. Okay. Set the denominator equal to 0 and solve it. Done. Right? Okay. So in answer to question number 1, what is the domain? Your answer would be the domain is all real numbers, so I can use my funky R, but x cannot be 0. Okay? That's one answer. How many answers do I need? 4, right? Okay? So out of that then comes answer number 2. What are the vertical asymptotes of this function? X equals 0. Not just 0, I don't know who said just 0, x equals 0 because a vertical asymptote is a line. Tessa, give me 5 minutes. I'll write you a pass if you need, okay? But this next 5 minutes, much easier if I'm here than on the video. Okay? 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 So that's 2 of the 4. The next one says that I need to describe asymptote behavior. So I need to figure out what the function is doing at my vertical asymptote. So here is where, and you guys were always complaining last unit how I always said it had to be in a specific form. I'm prepping you exactly for this, or I was prepping you for this. As x approaches, where is my vertical asymptote? At 0, right? So as x approaches 0 from the right, what is my function going to be doing? And as x approaches 0 from the left, what is my function going to be doing? Okay? So I've got this function. I'm looking at 0. So if I go to the left of 0, give me a number super, super close to 0, but on the left of it. Even closer, too far away. In terms of rational functions, that's 100 miles away. Negative 0.1 is much closer. Okay? So I'm going to go negative 0.1 on that side. Right? Because that's on the left of it. I plug that into my function. So I go 1 over negative 0.1. Right? It's going to give me a number. Right? Is that number going to be positive or negative? Why? So that's going to be negative, right? Okay? So as this number gets closer and closer and closer to 0, this bottom number is getting what? Smaller and smaller and smaller and smaller, right? Okay? Is it always going to be negative? Yeah. Okay? So this is always going to be a positive number divided by a negative small number. Fraction logic tells me that's going to go to what? A big number divided by a small number that's getting smaller and smaller and smaller. It's going to go to a what? So a negative infinity. Okay? So this number is going to go to negative infinity. Because that denominator, that bottom number, is going to keep getting smaller and smaller and smaller, which means that the fraction is going to just grow. So this left side is going to go to negative infinity. Now, let's apply the same logic, but over here. Positive 0.1 is on the right side of 0. Yes? Okay. So I would have 1 divided by positive 0.1. And this number is going to get smaller and smaller and smaller the closer and closer I come in to this 0. Right? So where's that one going to go? I'm going to have a positive number divided by a positive smaller and smaller and smaller number. Where's it going to go? Where's it going? Positive infinity. Okay. Now, the last thing we've got is our end behavior, and then you can get going, okay? All right? So the end behavior, that's going to be what we've already done. That's going to be as x is going to positive infinity, what is my function going to do? And as x is going to negative infinity, what is my function going to do? Okay. So again, just so I can rewrite it, just so that it's down here, f of x was 1 over x. So for this, I need to pick a really, really big positive number and a really, really big negative number. Million? Both cases? No. So if I have x equals 1 million, I plug that into my function, and I get 1 over 1 million. Right? Big, small, what is it? Small, positive or negative? Positive. And if that number keeps getting bigger and bigger and bigger, what's going to happen to my result? Smaller and smaller and smaller. So it's going to approach 0, right? From above or from below? Why above? Because it's positive. It's going to approach 0 from above. Because it's positive. If I do negative infinity, or excuse me, not negative infinity, negative 1 million, now I'm going to have 1 over negative 1 million, and that's just going to keep getting bigger and bigger and bigger, but in a negative way. And so what's that one going to go to? Small number divided by a huge number goes to, what do you got? 0, but it's, so it's going to approach 0 from, at left, below, yep, from below. So I'm going to go 0 from below because that's a negative fraction. Okay? Do you need a path? So with that being said, I give you these two. I'll give you these two things. First off, on this week's Purpley homework, you can do number 1 now. And on Wednesday, you need to bring your Chromebook because you will have 2 videos that you will need to watch on Wednesday in class. You can watch them in class. The first video is about 20 minutes long with notes, and then the second one will be about the same. So you'll have time to watch those. If you don't get through them in class on Wednesday, then they'll still be out on the interwebs and you can watch them at any point in time. But you need to watch those videos before Thursday's class.